Hi, today in IM1 we're going to discuss the focus of a parabola, so get your journal out and get ready. The cross-section of a satellite dish is in the shape of a parabola. Signals from a satellite strike the surface of the dish and are reflected to a single point, where the receiver is located. This is the focus. When the rays hit the parabola, they reflect at the same angle at which they answer. This means that this angle matches this angle. Notice we're taking the angles from the ray against the parabola, okay? Okay, exploration 1 reminds you that about the things that we just learned. Vertical rays enter a satellite dish whose cross-section is a parabola. When the rays hit the parabola, they reflect at the same angle at which they entered. So they want you to draw the reflected rays on this example so that they intersect the y-axis. So they gave you the angles on the first one, so you're just going to continue this line. And they want you to do the same. Remember, this is the angle that you want to match, okay? So then once you've done that, you're going to ask, what do the reflected rays have in common? And so we're going to look at that. So if you're done, okay, so here's what they should all look like. They should all be going right through there. And that is what they have in common. They all intersect at 1, 0, 1. And then it says the optimal location for the receiver of the satellite dish is a point called the focus of the parabola. Determine the location of the focus. Explain why this makes sense in this situation. So 0, 1 is also it's the focus, but it's also the best place for the receiver because any ray entering the satellite dish will hit that receiver, okay? And the question they want to ask is, will the focus of all parabolas be the point 0, 1? Why or why not? Not necessarily if it's been stretched, if it's been shrunk, especially if it has been translated to the left, to the right, up or down. That will not be the case. So remember, there are exceptions. Okay, exploration 2 looks at things from a slightly different angle. Beams of light are coming from the bulb in a spotlight. Notice the bulb is the focus. Okay, they're all starting at the focus. And now they're going out, so the light's going out this way. Okay? So when the beams hit the parabola, they reflect at the same angle at which they hit. Remember, the ingoing and outgoing angles should be the same. So see if you can get those beams drawn. When you're done, they should look like this. Notice they're all going out. What do they have in common? What does this mean? They are all parallel. Would you consider this to be an optimal result? Sure. Why? Well, when you've got a spotlight on something, don't you want all the beams pointing to what you're spotlighting? So with a spotlight, all beams of light should be pointed at the same object. Okay. So now we're going to talk about the directrix. A parabola can also be defined as the set of all points x, y in a plane that are equidistant or the same distance from a fixed point called the focus and the directrix. Okay? The focus is in the interior of the parabola and lies on the axis of symmetry. Those are very important points. So whenever you have a parabola, the focus is on the inside. Okay? And we're going to even look at some like this. So you want to make sure. Okay? The vertex lies halfway between the focus and the directrix. So here's our vertex. We know it's on the axis of symmetry. Okay? And there's also our vertex is also on the axis of symmetry. Okay? And then it says it's halfway between the focus and the directrix. So there's our directrix. I'm just going to draw one for both of them. And it is perpendicular to your axis of symmetry. So you've got your axis of symmetry. These are perpendicular. Okay? All right, so look that over really carefully. Make sure you understand all the rules. Okay? Okay, we're just going to go through some of the core concepts that you have to understand about the focus and the directrix. So the standard equation of a parabola with a vertex at the origin, meaning 0, 0, and the axis of symmetry is x equals 0, so it's the y-axis, has this equation. Okay, notice that it's 1 over 4p. P is the distance from the vertex to the focus and also from the vertex to the directrix. Okay, so if your focus on this one, since vertex is 0, 0, then the focus is 0p because you went up 2, or up p, I mean. Then that means your directrix would be negative p. Okay, so that's for a positive equation. Now, this is when p is positive. Okay, now if we say if your directrix is y equals negative p, keep in mind that this is for when p is less than 0, then that's going to go y equals negative p, so that makes your directrix y equals whatever it is, positive. So it's a positive directrix, okay? So just keep those kind of things in mind when they put a negative p and it's a negative number, you're going to be doing that, okay? So look carefully at the formula, make sense of it in your minds. Now, here is a horizontal axis of symmetry. This is when you have an equation that is, instead of y equals x squared, it's x equals y squared. Okay, this is our typical y equals x squared equation. You can have the quadratic, you can have a trinomial, a binomial, or the monomial like this one. And this one here is the basic. So again, it's 1 over 4p, and then you have the focus is p0. And so look carefully, look at all these different parts, push pause, spend some time looking at all these different things. Remember that this distance is the same as this distance, okay? So that's always true. Now notice when it's a positive p, then you have a happy face goes this way. Your happy face looks like that, okay? Meaning a positive graph. When you have a negative graph, then it looks like this, but your focus is still inside the parabola. Okay, the next page, page 102, just describes the difference in the equation when you have a vertex at another point. So, just like we did with writing things in vertex form, you have h and k. It's written all the same. The basic difference is this, okay? You add that when you're talking about the focus and the directrix. Alrighty. So I just made this quick little cheat sheet to remind you if it's y equals, it's a typical up or downward facing, and this is a positive p and this is a negative p, okay? X equals y squared, and then this is the positive p and this is the negative p. So look at it that way and help yourself understand. All right. And I say positive p or negative p because when I put it into the formula, negative 1 over 4p like this, then that I'm just giving the negative to the p to help you remember. Okay? All right. So these concepts are in the text on page 162 to 163. This parabola is defined such that all the points on the parabola are equidistant from the point 0, 2. That means that is my focus. And the line y equals negative 2. That is my directrix. Another point on the parabola is labeled xy. So it's just a random point that they picked. What do we know about this point? Okay, we know that this point is the same distance from the focus as it is from the directrix, because remember the definition. The parabola is defined such that all the points on the parabola, every single point on the parabola, is the same distance from the point of our focus to the directrix. Okay, so think about that. Maybe draw some lines and check it out. So, how do we find that distance? Okay, well, we would use the distance formula. So first we're going to find D1, that's this one, and that is the distance from xy to 0, 2, okay, which is our focus. So we're going to plug that in, going to do the work, And we're going to get d1 equals the square root of x squared plus y minus 2 squared. Okay? Got that? All right. So now we're going to find the distance from x1 to the line. Okay, remember the shortest distance is a perpendicular line, so make sure you do that. And that would be our equation. If we simplified, it would be the square root of y plus 2 squared, because x minus x equals 0. So remember, this is going to be one of the key things that you do in this section. So you want to understand that you're finding the distance from any point on the parabola to the focus and straight down to the directrix. Okay? So now we're going to simplify each of these distance equations. So there's the simplification. I already showed you on the other page. And what do we know about the relationship between d1 and d2? We know that they are congruent. So we can use that knowledge to find the equation of the parabola. We're going to set the two equations equal to each other. Okay? So now that we've gotten to this point, we're going to simplify until we get, cross out the things they have in common, we get x squared equals 8y. Now, we're not done yet. Remember, from the shape of the parabola that we saw, we knew that it was y equals. So we have to get the y alone, because when there's an x squared, that's the part that has to be alone. So we're going to get y equals 1/8 x squared. So look at that carefully. Now that we have that, we know that the standard form of the equation is y equals 1 over 4p x squared. And that tells us that p equals 2. So that gives you a lot of information there just by having this formula. Okay? All right. And there it is there. And we are good to go. Okay, now these problems in your journal were written to have you use the distance formula, but I want to show you how to do it without the distance formula. So the first thing I know is that I'm going to write an equation of the parabola with a focus of -8 and a directrix of 8. So the first thing I'm going to do is I'm going to draw these on a graph. Right away this tells me, because I remember that the parabola is always eating the focus, so this tells me that this is a downward facing graph. And since the vertex is the midpoint between these two, I know that the vertex is right there at 0, 0. So I'm going to write these things down so I remember them. Okay, now, the other thing I want to ask myself is, what is P? So I know P is the distance between the vertex and the focus. So P, in this case, is -8. So I'm going to take this formula, y equals 1 over 4p x squared, and I'm going to plug in the p, so y equals, I'm going to go over here, y equals 1 over 4 times -8 x squared, and so my formula is y equals -1 over 32 x squared. Now this works when you have the vertex of 0, 0. It's really easy to do it this way. On more complicated ones, you may want to use the distance formula. Okay, so let's have this. Now, the information that they gave you was that the parabola has a vertex of 0, 0 and a focus of 0, 1. So ask yourself, what is the directrix? What is P? See if you can figure those two things out. And go ahead and come up with the equation. Okay, so if the focus is 1, and we know that the parabola eats the focus, then that means the directrix is on this side. Same distance this way. And the distance, or P, is 1. So my directrix is y equals -1. Okay, so now I'm going to come up with the formula. Y equals 1 over 4 times 1 x squared. So there it is, and then y equals 1/4 x squared. Alrighty. So let's look at another one. In this one we have y equals 1/8 x squared. So you have to learn to identify. So what is p? So the first thing I'm going to do is I'm going to actually think 1 over 4p x squared. So 4p equals 8. So p equals 2. What is my focus? Okay, this is a positive graph. And since there's nothing added to it, there's no b or c in the quadratic, I know that my vertex is 0, 0. So that means my focus is up 2 from the vertex. So it is 0, 2. The graph is y equals, so it's vertically aligned, positive parabola. All right. Then the vertex, we already figured that out, is 0, 0. The directrix is go down 2 from the vertex, y equals negative 2. And then the axis of symmetry is x equals 0. So these are all the kind of things. This one happens to be a 0, 0 vertex, but remember, if it's more complicated, it will have that form. Okay, so in this problem in your journal, they're going to be asking you to find the focus, the directrix, and the axis of symmetry of the parabola. So look carefully at the parabola, the equation of the parabola, and notice certain things. So what I notice is that there's a y squared and x has no exponent. So this means I probably am looking at an equation with this form, which means it's going to be of this shape or this shape. So the first thing I want to do is simplify my equation. So I'm going to move the 1/3 x over to the other side using opposite operations. And then I'm going to divide off my coefficient of x. And we know that when we do divide a fraction by a number, we can just go ahead and multiply by the reciprocal. And we're going to get y equals positive 1/15 y squared. So that doesn't give us everything that we need, so we're going to keep going. So I know that 1 over 15 is my 1 over 4p. So I divide 15 by 4, and I get p equals 3.75. Now, because this is positive, we know that it's a happy facing graph. So if I go over 3.75, I'm going to put my focus right there. So my focus is 3.75, 0. Okay? And my vertex is 0, 0 because I don't have a B or a C here. So my vertex is 0, 0. And now I want the directrix, which means I'm going to actually, that line disappeared. I'm going to go back 3.75 because they have to be the same distance. You should draw with a ruler. My line is x equals negative 3.75. And that is my directrix. Okay, and so that's the focus, the directrix. Oh, what is my axis of symmetry? Well, the axis of symmetry contains both my vertex and my focus. So I can see right here that my axis of symmetry, and remember we always write it as a line, is y equals 0. Okay, so that's everything you need to know. Here's what your graph should look like. On this one, the directrix doesn't show. That's why I wanted to draw it for you. And you are good to go. All right. Now for this one, they want you to write an equation of the parabola. So the one thing that's important to see right away is that my vertex is 0, 0. Okay, remember our standard form. This is a happy face graph is y equals x squared, or y equals 1 over 4p x squared. So that's what you need to remember. So look here, my focus is at 0, 5. So that means p equals 5, which means my equation is going to be y equals 1 over 4 times p x squared. And so my equation is y equals 1 over 20 x squared. Okay? And that is the equation of your line. There you go. That's it for today. You try the rest.